Right now, you're perfectly still. Or at least, it feels that way. You can feel the chair you're in, the floor under your feet. The world around you seems stable, fixed, reliable. But this feeling of stillness, it's the most profound illusion you've ever experienced. It's a lie your senses have been telling you since the moment you were born. Because right now, this very second, you are hurtling through the cosmos at a speed so immense it completely defies everyday comprehension. This isn't a metaphor, it's a physical reality. You are a passenger on a spinning world, a world that's falling around a star and a star that's trapped in a gravitational dance on a scale that borders on unbelievable. You've been traveling at roughly 500,000 miles per hour, or about 800,000 kilometers per hour, since the day you were born. Not in a car, a plane, or a spaceship. You are in a constant, inescapable orbit around an invisible tyrant, a silent anchor over 4 million times more massive than our Sun. This is the story of Sagittarius A star, the supermassive black hole at the center of our galaxy, and how you've been circling it, unknowingly, your entire life. Our journey to understand this invisible ruler begins by peeling back the layers of motion, a kind of cosmic unmatryoshka of movement that defines our existence. Let's start with the familiar. Right now, depending on where you are on Earth, you're being carried by the planet's rotation at up to 1,000 miles per hour. We never feel it because everything, the air, the buildings, the ground, is moving with us. It's our first clue that our senses aren't built to perceive our true motion. But that's just layer one. As we all learn in school, the Earth is in a perpetual orbit around our home star, the Sun. To stay in this cosmic loop, our entire planet barrels through space at a stunning 67,000 miles per hour, or about 107,000 kilometers every single second. At that speed, you could cross the entire circumference of the Earth in under 3 minutes. This is the speed you have been traveling your whole life, carried by the Sun on its immense galactic journey. This journey is so vast that one galactic year takes about 230 million Earth years to complete. The last time our solar system was right here in the Milky Way, the first dinosaurs were just starting to roam the Earth. The time before that, the planet was a barren landscape, long before the great explosion of life in the Cambrian period. The mountains, the continents, the oceans, they are all temporary features that have risen and fallen over just a few laps around the galaxy. And here's the core of the revelation. An orbit this huge, this fast, implies a powerful gravitational pull. But it's not just one object. For our solar system to be held in this path, it must be orbiting the combined mass of billions of stars, gas, dust, and dark matter concentrated toward the galactic center. It's a gravitational anchor of almost unimaginable scale. At the very heart of that center, there must be a focal point, a silent, invisible sovereign. But what could possibly sit at the exact center? What is this invisible object we've all been orbiting since the dawn of our species? The object at the heart of our galaxy has a name, Sagittarius A star. Pronounced Sagittarius A star, it's located about 26,000 light-years away, in the direction of the Sagittarius constellation. If you look up at the summer night sky toward the dense, bright river of the Milky Way, you're looking toward the galactic core, toward our silent ruler. But you'll never see it, not with your eyes, not even with the most powerful optical telescopes. The path to the center of our galaxy is choked with vast, thick clouds of interstellar dust and gas. For a long time, astronomers referred to the broad, obscured plane of the Milky Way as the zone of avoidance because this dust hides so much of the universe beyond it. Imagine trying to see a single street lamp 100 miles away through miles of dense, unending fog. That's the challenge. This dust is so effective at blocking visible light that it has shrouded the heart of our galaxy in a permanent veil. This is why we call Sagittarius A star an invisible tyrant. For all of human history, its gravity has been shaping our cosmic destiny, yet it remained completely hidden. The word tyrant might seem dramatic, but it captures the absolute nature of its influence. It doesn't think or act, it simply is. Its existence is a fundamental law that our little corner of the galaxy must obey. Every moment of your life has been spent in motion, dictated by the gravitational field it helps anchor. Its influence is as profound as it is subtle, a constant pull that has become the fabric of our galactic neighborhood. That's what makes its invisibility so compelling. We're in a constant dance with something of unimaginable power, yet we can't see it. It's a cosmic ghost, a silent partner in a dance we didn't even know we were a part of. To find it, to prove it was real, astronomers had to learn to see the universe with a different kind of sight. They had to peer through the dusty veil and uncover the secret the Milky Way had been keeping for eons. The story of how we found Sagittarius A star is a great detective story. It began not by seeing, but by listening. In the 1930s, a radio engineer named Karl Jansky was trying to identify sources of static interfering with radio transmissions. He built a large rotating antenna and found a faint, steady hiss coming from the center of the Milky Way in the direction of Sagittarius. He had, without realizing it, detected the first whispers from the galactic core. This was the key. While visible light is blocked by dust, other forms of light, like radio waves and infrared, can pass right through. By switching to these wavelengths, astronomers could finally pierce the cosmic fog. In 1974, astronomers Bruce Ballack and Robert Brown pinpointed a bright, compact radio source at the very center of the galaxy. They named it Sagittarius A star. But knowing something was there wasn't the same as knowing what it was. The real proof would take decades more. The definitive case came from the monumental work of two independent teams led by Reinhard Genzel and Andrea Ghez. For their discovery of a supermassive compact object at the galactic center, they, along with theorist Roger Penrose, shared the 2020 Nobel Prize in Physics. Their method was simple in theory, but breathtakingly difficult in practice. They decided to watch the stars orbiting this invisible point. Just as we can calculate the sun's mass by watching the planets, Genzel and Ghez realized they could weigh Sagittarius A star by tracking the stars zipping around it. Using the world's most powerful infrared telescopes, they began a project that would span more than 20 decades. They developed new technologies like adaptive optics, which uses deformable mirrors to cancel out the blurring from Earth's atmosphere, giving them an incredibly sharp view. Year after year, they mapped the positions of stars orbiting the central point at incredible speeds. One star became the smoking gun, S2. It whips around Sagittarius A star in a tight orbit that takes only 16 years. Our Sun, by contrast, takes 230 million years to make one lap. As S2 neared its closest approach, it was clocked moving over 7,650 kilometers per second, about 2.5% the speed of light. By tracing its full orbit and applying the laws of gravity, the teams came to a staggering conclusion. To hold a star in such a fast, tight orbit, the central object had to contain the mass of roughly 4 million suns. And all of that mass had to be crammed into a region of space far smaller than our solar system. There is only one thing known to physics that can be that massive and that compact: a supermassive black hole. The silent, invisible tyrant finally had its identity confirmed. So, what exactly is this 4 million solar mass monster we orbit? At its most basic, a black hole is a place where a huge amount of mass has been squeezed into an impossibly small volume. The gravity is so powerful it warps space-time, creating a one-way door in the universe. We're familiar with stellar mass black holes, which form when a single massive star collapses. Sagittarius A star is a different beast, a supermassive black hole, the kind that lives at the center of most big galaxies. How they form is still debated. Some might have grown over billions of years by gobbling up stars and gas, while others might have been born as giants from the start. Whatever its origin, Sagittarius A star is defined by a few key things. First, its mass. Saying it's just over 4 million times the mass of our Sun is an abstract number. Try to picture our Sun, which holds 99.8% of everything in our solar system. Now imagine 4 million of them crushed into a single point. This concentration of mass creates the event horizon, the famous point of no return. It's not a physical surface, but an information barrier. Cross it, and you can never get back out, because you'd have to travel faster than light, which is impossible. The size of Sagittarius A star's event horizon is about 15 million miles, or 24 million kilometers in diameter. That sounds huge, but for something so massive, it's incredibly compact. If you placed it where our sun was, its entire event horizon would fit easily inside the orbit of Mercury. But a black hole isn't a cosmic vacuum cleaner. If you replaced our sun with a black hole of the exact same mass, Earth's orbit wouldn't change at all. The danger comes from its compactness. It lets you get much, much closer to all that mass. Around Sagittarius A star isn't a bright, classic accretion disk like you see in movies. Instead, it has a hot, thin, swirling flow of gas that has been captured by its gravity, but hasn't fallen in yet. As this material spirals inward, it's heated to millions of degrees, causing it to glow in X-rays and radio waves. This glowing, superheated gas is what astronomers actually observe. Interestingly, Sagittarius A star is considered a remarkably quiet black hole. Compared to the blazing quasars in other galaxies, ours is barely snacking. One popular analogy suggests